I want to find the series and the radius of convergence of this function. So I want it to look like 1 over 1 minus x. So I pulled out the x squared and then I did 1 over 1 minus a negative x because that's just making it, I still want 1 minus x. So I have to, instead of pulling out a negative, I just put the x as a negative x. So then I can put the negative x into the series of x to the n, but I have the negative x, so I put, in the x place, I put negative x, and I have the x squared out in the front. And then you just want to simplify a little bit to where the negative is a negative 1 to the n power, and then x to the n power, and then I still have the x squared outside, and then I pulled the x squared into the series, and then you just add it to the x of n. So it's negative 1 to the n power x of n plus 2. And now I want to find the radius of convergence. So then I did the ratio test, and then you take the limit of n go to infinity of an plus 1 over an in the absolute value. And then to do that, you do the limit as n goes to infinity of negative 1 to the n power x of n plus 3, because x to the n plus 2, then n gets another 1 added because of the n plus 1, so then it becomes plus 3, and then over the original function. And then you just can simplify that out. I took out the negative 1 to the n power because of the absolute values, but I still want to keep it in there because of the x's. And then you can take out the x of n's, they cancel out, and then you can simplify it, and it's a positive x in the numerator. And that's all less than 1. So the radius of convergence is 1.